Welcome to Database Mart channel. In this video, we'll take a deep dive into the inference performance of the NVIDIA H100 under the vLLM framework. We used a GitHub project to set up the environment and selected 6 mainstream models, ranging from 9 billion to 32 billion parameters from Hugging Face. Each test used a fixed input of 100 tokens and generated 600 output tokens, running a total of 300 requests. The NVIDIA H100 server configuration is as follows. We first tested Google's Gemma 2 instruction-tuned model with 9 billion parameters, which has a size of 18.5 gigabytes. It can handle 27.03 requests per second, with a total throughput of 3,269.80 tokens per second and a GPU utilization rate of 93%, fully unleashing the computational power of the H100. The H100 not only achieves high throughput and utilization, but also maintains stable performance output, indicating that the H100 is fully capable of meeting the inference demands of such medium to large language models. The second test was Google's Gemma 2 instruction-tuned model with 27 billion parameters, which has a size of 54.5 gigabytes. When deployed on the H100 GPU, it can handle 8.95 requests per second, with a total throughput of 2,271.06 tokens per second. GPU utilization remained between 86% and 96%. Compared to the 9 billion version, the processing capacity decreased, but the model still demonstrated stability in throughput and resource usage. The third test was 8 billion parameter distilled version of the DeepSeek R1 Llama model, which has a size of 16.1 gigabytes. It can handle 8.80 requests per second, with an impressive total throughput of 5,933.63 tokens per second. GPU utilization remains stable between 83% and 85%. Although its request processing speed is slightly lower compared to other models, it demonstrates exceptionally high token-level throughput in generation tasks. The fourth test was 7 billion parameter distilled version of the DeepSeek R1 Qwen model, which has a size of 15.2 gigabytes. It can handle 10.79 requests per second, with a total throughput of 6,882.47 tokens per second. GPU utilization fluctuated between 50% and 91%. Although GPU utilization shows some fluctuations, the server still delivers strong performance. The fifth test evaluated the 14 billion parameter distilled version of the DeepSeek R1 Qwen model, which has a size of 29.5 gigabytes. It can handle 9.81 requests per second, with a total throughput of 4,821.08 tokens per second. GPU utilization remained between 80% and 90%. Overall, the larger model size introduces a higher computational load, resulting in slightly reduced processing speed and throughput. However, the H100 still handles both versions of the model well. The final test was 32 billion parameter distilled version of the DeepSeek-AI Qwen model, with a model size of 65.5 gigabytes. It processes 2.67 requests per second, with a total throughput of 1,481.62 tokens per second. GPU utilization remains between 92% and 96%. Compared to smaller scale models, the 32 billion version experiences a significant decrease in request processing speed and throughput. This indicates that although the H100 can support inference for ultra-large scale models, there are evident bottlenecks in response speed and throughput. Based on the above test data, it is clear that the H100 demonstrates powerful computing capabilities and excellent model compatibility in vLLM inference scenarios. It is especially well suited for deploying medium-sized models ranging from 7 billion to 14 billion parameters, balancing high throughput with low latency. If you are looking for a GPU platform capable of supporting high concurrency, large model inference, the H100 is undoubtedly a choice worth considering. Thanks for watching. If this video was helpful to you, don't forget to like, comment, and share. Follow us to learn more about servers.